Hi everyone, this is Tom Cherryholmes with another entry in the Retro Computing Archaeology series. In this video, we're going to explore the commonly held belief that some of the very first games for the ColecoVision were written in Pascal. We're going to take and either validate or invalidate this assertion using a set of forensic tools to confirm the lore and show the value in making and creating such tools to settle long-running debates in the retro computing community. To start, the ColecoVision itself is a Z80-based game console with a TMS 9918 video display processor and a TMS 9919 sound processor. It has a lot of wonderful features, such as being able to do many sprites on the screen, and Coleco really did a number to take and quickly put this machine through development and into production. And in order to facilitate that, it was said that a number of the games were written in Pascal, and this includes Donkey Kong. Oops. Exit. Try that again. Yes, I'm doing this stuff live, so I apologize ahead of time if things go a little sideways. We'll try to deal with it appropriately. We can see right here the game of Donkey Kong as it shipped for the ColecoVision here, supposedly written in Pascal. And this is one of the games that we're going to take and verify to see if this is actually the case. I'm going to show essentially how I take and establish context here, how we take and create the tool, and use the tool to take and either confirm or disprove these assertions. But first, a little bit of historical context. To quickly get things going at Coleco, they used a development system, and in point of fact, they rented these development systems out. This is the HP 64000 microprocessor development system. It was announced at the end of 1979 by Hewlett-Packard, and quickly became a very well-adopted standard for quick bring-up of microprocessor-based devices, such as game consoles. And there were a number of good reasons for this. It had everything that you needed in order to take and make microprocessor software. This included a full-screen text editor, a complete assembler for a number of processors, a debugger also for a number of different processors, an in-circuit emulator or ICE, which allowed you to take and plug into the processor socket of the board that you were developing to tie into the debugger so that you could get cycle-by-cycle analysis of the code that you were writing. But it also provided, in order to take and speed up development, two compilers, two cross-compilers, to allow you to write software not just in the assembler language of the desired microprocessor, but also in high-level languages like Pascal and C. And in point of fact, if we take and zoom in a bit more into this document right here, we see HP 6 Series 64800. This was the part number given to the cross-compilers for the Pascal and C languages that were available not only for the HP 64000, but also for other mini-computers of the time, such as the HP 9000 series and the VAX from Digital Equipment Corporation. So you had a lot of options for doing software development. And in point of fact, if we actually take and zoom in just a little bit further, we'll take and scroll down a little bit here and come up to the top here, and we'll see in our table of contents, we see specific cross-compiler information and see that our cross-compiler was available for a variety of different processors, including but not limited to our venerable Z80 present in the ColecoVision. Moving a bit forward, so that leads us to our next document here, and we'll find right here we have a copy of the ColecoVision Programmer's Manual, Revision 5, dated 1982. Of course, it's a confidential document. This was what Coleco handed out to the programmers so that they could take and write their software. And there's a lot of great information inside this particular document. But since we're looking for whether or not a particular piece of software used a set of routines for Pascal, it really behooves us to take and look closer at the Appendix E here for the jump table. And we see a number of different routines here. Play songs, reflect vertical, controller scan, show game options, load the ASCII character set, fill VRAM, and etc. But you'll notice that some of these, you'll see different jump instructions for things like write VRAM, read VRAM. But interestingly enough, you'll also see write VRAM P, write register P, free signal P, init sprite order P. What are these? Well, it's safe to pretty much assume that these are Pascal entry points. And that if we were to take and possibly scan the cartridge binaries for these entry points, we could get a pretty good idea whether or not a particular game was written in Pascal. But let's dig a little deeper and establish a little more context. Oh shit, I realized. Going into another confidential document here, this is the official. These are the official listings for the Atom EOS and for the ColecoVision OS7. The ColecoVision, the Coleco logo is cut off on the top right here because I've cropped this image a little bit to make the listing the important thing we want to focus on. But I showed you this page just to show you that this was official. This is the official documentation for programming the Coleco Atom. And it's really kind of interesting because this is a source listing, and it's a good example of why source code listings are so important, and that whenever you find them as an archaeologist, you want to try and preserve them at all costs because they can end a great many arguments by providing a first-hand canonical source that you can reference. If we take and dig into them here, hold on just a moment while I bring up my appropriate listing here, we find, for example, down here at page 422, right at the end, give it a moment because this is a very large scan document, we will find our ROM jump table. And you'll see right here, Hewlett-Packard. This indicates that this came off of the HP 64000 development system. The file name that was the file name on the file system for our ROM here, which is the OS7 Prime. It's Prime because this was the officially released version of the operating system ROM. And we can see that this listing was produced on the 18th of May, 1984 at about 4:20 p.m. So if we look here, we'll see ROM jump table. And it says right here, this is the jump table to be used in accessing code residing in the OS ROM. Okay, cool. This is awesome. So let's take and dig down a little bit here. Ooh, okay, we see an entry here for write VRAM P, which jumps to VRAM write Q, okay? If we take and decode this instruction ever so slightly, it put this at 1C BC here, which is over here on page 406. And we'll see. Ooh, this is the parameter description for write Q here. And some interesting things to really note. What you're looking at here in this particular portion of the ROM is actually a Pascal interpreted section where you have the Pascal source code up here, along with the equivalent machine language instructions down here. So not only were these particular versions of the routines set up to handle gathering their parameters in Pascal form, but the routines themselves were written in Pascal to begin with. So that really opens up a whole area of research here to take and reconstruct this just by pulling out the source code bits in the routines here so that we can have the original routines before they were taken and compiled. An interesting area to go through to be sure. And we see more references to Pascal here, such as the procedure keyword and how parameters are specified in Pascal with the variable name and then the type versus the type then the variable name in languages like C. So we dig in a bit further and we realize, okay, we've got a good case here. We know that these routines exist in the ROM and that they were present in the programming manuals that were given to the software engineers after the firmware engineers had finished writing the firmware, or maybe in parallel even. But that's just conjecture. So how do we take and confirm this once and for all to see, A, if these games actually did use Pascal routines, and B, perhaps if they did, which games would actually use them? Well, the best way to do this would be to take and write a tool. Well, what would this tool essentially do? Well, if we take and now go into my terminal display here, I will actually take and flip my terminal window over here over to find-pascal here, which is a workspace, a little tool that I've written here that does exactly what we're asking for here. Let's go ahead and open it up. And we can see the name of the tool here and some brief explanation as to how it works and why it works. What this tool does is it grabs a file name to scan. It subsequently opens that file, errors out if it can't, and reads each byte of the file. Starts to pull it all in, one character at a time. And it looks for a particular instruction. In this case, the common way to call subroutines in Z80 is to use the call instruction. If you look in your Z80 programming manual, you'll find that call has the byte number CD, hex CD for call. And if we find that byte, it's safe to assume that we can assume that the next 2 bytes are the address of that instruction. Cool, we can do that. We take and read in, and then we read in the next 2 bytes, and subsequently take and scan through a table that I've defined above in the code here. And if we find something that matches, we set that it does. We print the name of the file, okay, and then print a formatted statement, which is tab, and the name of the function that we find. Finally, we take and close the file and return to 0. Well, what's in that table? That table consists of all of the vectors that you saw on the other page here on the programmer's manual, along with their names and their addresses. And all we have to do is take and match. And if we get a good number of these matches, it is safe to assume, pretty well, we can reasonably assert that a particular game was written in Pascal. So what does this look like? Well, let's try it out. To do this, let me go ahead and move back to my terminal here. To do this, we will actually stop the emulator that I have running over here. And I have a library of ColecoVision games. If we take and look inside the A folder, we'll see ROMs beginning with A and B. These are all the ColecoVision ROMs that I could find here, all alphabetized and just right here, ready to be processed. It turns out that processing them is actually very easy. We can use Unix's text processing facilities here to take and scan through each one of the ROMs that we find and run our find-pascal program. If we run find-pascal, I've already compiled it and installed it on my system here. We can say find-pascal file name. Okay, and we can use Unix's text processing features here to quickly take and scan through all of these ROMs and see which ones are potential matches for games that were written in Pascal. And it turns out this can happen very quickly, especially because this particular tool is written in C. It's very small and it's very fast. That's it. Boom. Within a fraction of a second, we've scanned all the ROMs and we've got some matches. Let's take a look. The first one that we see is, of course, the one that we pretty much knew and understood to have been written in Pascal, which is the first version of Donkey Kong, which was a 24K ROM that was released as the pack-in for the first versions of the console. And we see a lot of calls to various things, writing VDP registers, signal management, testing signal management, and lots of calls to the sound music player. We can reasonably assert from all of this, especially if you take and compare it to the table of entry points that are in the programmer's manual here and the number of times that these things match, we can reasonably assume that this version of Donkey Kong is written in Pascal. Now you may notice that one of those games, if we actually take and go and look at Donkey Kong, we'll see that there is two versions of Donkey Kong released. The 24K ROM, which is what we matched up against above, and the 16K ROM, which has a later date. You'll notice that the later ROM does not contain and doesn't match at all. We don't get it back at all. So we know that we're not matching, we're not having false positives matching data, and that virtually none of the code in the second version of Donkey Kong contains any calls to Pascal and was actually rewritten in assembler. What were some of the other games here? Well, we'll see that Smurf Rescue and Gargamel's Castle actually has many of the same initialization routines, register write routines here as our Donkey Kong here. So we can reasonably conclude that it too was written in Pascal. We have a match here for boot disk. That's not a ROM, so we really don't have to worry about it. And we do have a match here for Zaxxon for write VRAM P. This one would need to be studied a bit closer to see if this is actually just a match somewhere in the data section of the ROM, such as graphic tiles, etc., given that this is the only match here and that there are no corresponding initialization routines being matched, anything like that, we can pretty much assume that Zaxxon was not written in Pascal, or if it was, that a good portion of it was ported over to assembler. So that gives us essentially, in one fell swoop, we were able to scan the entire collection of my ColecoVision ROMs contemporaneously to find that Donkey Kong and Rescue in Gargamel's Castle are reasonably certain to have been written in Pascal. I hope this has been a good demonstration to show you how writing forensics tools to take and pull together a whole bunch of different pieces of archaeological knowledge can be used to settle arguments, disputes, and potential assertions relating to the field of computing history. I hope you guys have had fun, and I hope you find these particular videos instructional here. And I will be trying to make them more as time permits. But until next time, guys. Have fun.